Section 5.6, the quadratic formula. Please write down the essential question. How do I solve quadratic equations using the quadratic formula? So here are all the methods used to solve quadratic equations. We've used a graphing calculator, we've factored, we use the square root method. Remember, that can only be used when b equals 0, completing the square, and now the quadratic formula. All of these methods will generate the same roots, zeros, x-intercepts. Sometimes a quadratic equation is not factorable. Then we go to the other methods. The one method that always works is the quadratic formula. And this just goes through an example of the quadratic formula and the equation for it, which I'm going to summarize on the next page. Here's the quadratic function equation, ax squared plus bx plus c equals 0. A cannot equal 0 because, and we've already talked about this, if a is 0, that means that goes away, and then you change from a quadratic to a linear, and that's not what we're dealing with. Then the solutions or roots, or we can call them zeros, and sometimes they're x-intercepts, but if they're imaginary, they're not. So I'm not going to mention x-intercepts right now. We'll call them roots and zeros. And here it is. The one thing I want to point out is when they talk about the discriminant, that is just what's under the radical. So you want to memorize this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is part of the quadratic formula that you can use to determine the number of real roots of a quadratic equation. Remember, when we're dealing with imaginary roots, those are non-real. So the discriminant is going to tell us the number of real roots. Back a minute. Okay. All right. Lost my real roots. You can use the quadratic formula to solve any quadratic equation that is written in standard form, including equations with real solutions or complex solutions. So you can still get complex solutions using the quadratic formula. Those are the ones that have I involved. You can use completing the square to check the answer you get using the quadratic formula, because remember, they're all going to give you the same answer. Example 1. Find the zeros of the function using the quadratic formula. So we're not going to try to factor that. It's not factorable anyway. I can't find two numbers that multiply to -7 and add to 3. So over here, we're going to write what A is, what B is, and what C is. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. When I start plugging in each of the numbers a, b, and c, I'm going to show you something. So bring down the negative in place of b, write b. Notice I'm using parentheses everywhere I substitute a letter, a, b, or c. Right here where it's minus 4ac, I'm going to change that minus to, well, first it's minus. I'm going to show that first. 4ac. I can change a minus to a plus, a negative. And I'm going to do that because that's going to help alleviate errors. So -3 plus or minus. So we have 3 squared is 9 plus -4 times 1 times a -7 is a positive 28 all over 2. So we get -3 plus or minus. We have 9 plus 28, which is 37, and the whole thing is over 2. Notice that this whole thing is over 2a, not just the radical part. And honestly, we would stop right there because I can't simplify that radical. Again, if you're thinking I don't see two answers, well, the two answers are -3 plus the square root of 37 over 2 and -3 minus the square root of 37 over 2. Example 2 we're going to do in class, and example 3 I'm going to do right now. Find the zeros. There's our function, and we're going to use the quadratic formula. So x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to write down what a is, what b is, and what c is, and plug it in. -b, b is squared. I'm going to do plus a negative. Instead of -4, I'm going to do plus a -4. A, C, all over 2A. 3 squared is 9 plus a -4 times 4 is a -16 times 2 is a -32. That's why I'm having you do plus a negative, because then you know when to give the negative, when not to. And that's where I see most the errors is right here. 9 plus a -32 is a -23. And the minute I see that I have a negative under a radical, I know that it's going to be a complex number. So I'm going to take the I out. And there we go. You never want to leave your answer with a negative under a radical. So again, if we wrote the two answers, it would be -3 plus I root 23 over 8 and -3 minus I root 23 over 8. Plus or minus I. There we go. Example 4, we're going to save for class. And now I'm going to talk about the term discriminant. Remember, way back at the beginning, we said the discriminant was the part that was underneath the radical. Okay. So the discriminant is going to be b squared minus 4ac. When that is greater than 0, there are two distinct real solutions. When it equals 0, there is one distinct real solution. And when b squared minus 4ac is less than 0, there are two distinct non-real complex solutions. Because what that's saying is what's under the radical is a negative, which generates an answer that's an I. And look at the graph. Two distinct means you're going to cross the x-axis twice, and we can call them x-intercepts, zeros, roots. Here, this is a double root. And here it's not crossing the x-axis. And when that doesn't happen, that it means it is an imaginary, or we can call it a complex solution. Caution, make sure the equation is in standard form before you evaluate the discriminant. Right. So make sure it's always ax squared plus bx plus c. All right, so here we go. I'm going to get it in standard form right now. I'm going to minus the 12x And so I'm going to get x squared minus 12x plus 36 equals 0. I can see that A is 1, B is negative 12, and C is 36. And there is my quadratic formula. But guess what? It's not asking us to find the zeros. It's only asking us to find the type and number of solutions. So all we care about is the discriminant, that part. All right, so let's do it. So we have b squared minus 4ac. Again, I'm going to do plus a negative. So that's 144 plus, we have a negative 4 times 1 times 36 is a negative 144. That is equal to 0. So therefore, we have one distinct real solution. And I'm going to be fine. I'm not going to be too worked up about the word distinct. If you just say one real solution, I am fine. But the real is important. You need that. 6 and 7 we're going to do in class. And the final page here shows a graph of relating three different functions, the blue, red, and green. They all have the same A value and B value, and the only difference is their C value, which is showing how they're changing. So notice that the number of real solutions for the equation can be changed by changing the value of the constant C. That's exactly what's happening here. The green is going to have two complex solutions. The red is going to have one real, and the blue is going to have two real solutions. You can tell that by looking at the graph, and we can also figure that out when we use the discriminant, which explains it right here. And then it talks about all the different methods that we've talked about to find the zeros. No matter which method you use to solve a quadratic equation, you should get the same answer. And here are the video questions. Please do them in your notes.